Am I on? We can hear me at the back. Good. Hi everyone. My name's Don. So it's language programming, language designer morning. You got Joe just now, and now it's my turn. I think we have Hardy. Is Hardy here? I'm not sure if he's in the audience. Later on in the day, he's going to be talking about the Kotlin language design. But I'm going to be here telling you about part of the journey of F#. And what better place to talk about the F# path to relaxation than here in Malaga? I'm going to be talking about things about how, the core job of a programming language designer, and in fact many parts of life in general, but is to take things that are in tension, things that seem that can't be reconciled, things that are impossible to bring together. A lot of these great ideas from the past that Joe was talking about. The biggest problem about getting them into practice is actually taking the idea and combining them with existing ideas and existing practice to bring together something that is that gets the best of both worlds. That brings a new unity out of two conflicting ideas. So I want to take that basic idea that things are in conflict, and that through that conflict we can make a better world. We can make head in sort of directions which are neither A nor B, but in a new direction, a synthesis between various ideas, and that is how we make progress in the field of programming language design. So to me, when you have these sort of disputes in computer science, say one great dispute that I've been involved in a way is functional programming and object-oriented programming. And I'm going to be talking a bit about the tensions and what we did in the F# language design to take this wonderful, incredible world of functional programming and to take this incredibly practical world of object-oriented programming and to find a synthesis between those two that actually works in practice. And the F#, I want to talk about the F# approach to that problem. But that's a more general thing, that when we have these disputes, these tensions in design in computer science, it might be a design between, for instance, in the F# language design, you have something called pattern matching. And then you have another goal that you want, which is performance. And you have another goal that you want, which is abstraction and information hiding. And how can you make these things work together so that they're not tearing each other apart, but actually work in a synthesis together? So these disputes are, for the computer science researcher or the programming language designer, these disputes are the sort of starting point. You look for a place where there's conflict, or you look for a place where there's things that are in tension and not working together, and then you work out how you can make a simpler and more relaxed world from achieving that synthesis. The point of that synthesis is not to make something more complex. The point of that synthesis is to resolve the conflict and to make a world that is simpler, more relaxed, happier, where you don't struggle between two conflicting goals. So I know a lot of people here are Java programmers, but quick hands up, how many people work on the JVM? How many people work on .NET? Okay, great, we've got a bit of a mixed group there. I haven't resolved that conflict. Sorry guys, I know it's a big one. I am the one who was originally responsible for .NET generics, which all the .NET programmers here will be using. And I think that's also a great example where we had, how do you combine generics and still get performance and code specialization, and still get dynamic loading, and still get all the great libraries and binary compatibility that you get from the .NET ecosystem. I think all the people who are using .NET will understand how well generics work in the context of C# and F#. And again, it's part of this theme, that you take these conflicting goals and you make systems that actually resolve that conflict. So this is not a new idea. Who's this? How many people know who this is? This is the Hegel, yeah? This is back from the 1800s. And at the core of Hegel's, how many people have read any Hegel? Yeah, no, I've tried. It's really, really hard. Yeah? How many people here are from Germany? Have you got anyone from Germany? How many people here are from Stuttgart or Schweden? Excellent. I've been told, on the authority of my wife, that only people from Schwabian can understand Hegel. So, that he wrote in Schwabian and his German that he uses is only comprehensible to the Schwabian mindset. So if that's true, you should go away and read Hegel. But he had this basic idea at the core of his philosophy, which was then expanded on in, especially through the communists of the world, that we have this, we have an idea and we have the opposite of that idea and we have contradiction. And it's actually in the resolution of this thesis and antithesis that we get change through synthesis. And this was very much taken up as being a sort of core of human progress in the Hegelian dialectic. Now, this can be you can take this just a little bit too far. And my friend Thomas Petracek, when he heard that I was giving a talk where I was going to talk about contradictions and their resolutions, actually said, he's a philosopher, he's a computer scientist as well, and he's into the philosophy of programming languages. He says, I know, what you're really talking about is mustard watches. So this is this famous thing where someone was taking a bit of fun at this idea of resolving conflicts. You can't do this too far. That if you have this conflict between the idea of time and food, and you need to resolve this sort of conflict between this, then it's one of these papers that sort of pokes fun at these core themes in philosophy. So you can take this too far. There are some things that aren't in conflict, that are truly just different spaces. But there are many things in computer science which are in conflict. And I want to go back, this is in part retelling the history of where F# came from. What were we doing when we started with F#? Why did I sit down in 2003, roughly, and sort of write the first line of the parser for the F# implementation? And at the core of the matter was this big thing going on in functional programming at the time, which that functional programming languages on the left here were isolated from the world. They couldn't interoperate with these with the rest of the world. And that had many manifestations, but there was this feeling that whatever value we had over here had to be relocated. Either you had to build in lots of functional sort of interop features into the virtual machines that were being used over on the functional side, or you had to, the approach that we took was to say, actually, we better relocate where we're doing functional programming. And so if we roll back to 2003, so functional languages here, they were isolated, they weren't interoperable, they used their own virtual machines. That was the situation we were in. Way back in the day, people did interoperability through, well, C calls, people do that, and native interop. COM, that's still around a bit. There was this thing called Corba back then. Anyone still using Corba? There's always a couple. Okay, sorry. Okay, so there's Corba is something. I don't know what it does, but it did interrupt back then. And then everyone did lots and lots and lots of XML back then, and it was a mess. This wasn't how interop was meant to be, and certainly functional languages weren't playing well in that space. And so the F# approach, and it was one that's also subsequently used by Scala, and of course much more recently by languages like Swift and Kotlin. And we now take this it's totally normal to do this, that if you're going to make a new programming language, you locate it alongside one of these industry standard runtime layers. Scala's alongside the JVM, F# is alongside .NET, Swift is alongside iOS, and Kotlin is primarily, well, has several options like F# and these others as well, but it's in the Android system in particular. So you embrace these industry standard runtime layers, okay? Well, you try and influence them where necessary. One of the big reasons why I did .NET generics, and we made sure we did it right in the virtual machine, as the .NET programmers will appreciate, is because it actually makes it a very suitable language, runtime system for F#. Okay, so we did it for C#, but we did it for F# as well. And we designed the language, we're willing to let the language design change a bit to enable interop, to keep interop in mind, and maybe we make a few compromises where necessary. So this is absolutely crucial. F# is not Haskell.NET, it's not OCaml.NET. It's not like trying to take one of the existing functional languages and just say put it onto .NET. We're going to actually take the ideas of functional, the spirit of functional programming, particularly in the OCaml line originally for F#, and make that really fly in the context of the industry standard virtual machine. So this has worked absolutely amazingly well. It is, as I said, now the industry standard way of doing things. These functional languages are incredibly interoperable. Thousands and thousands of packages. You can use C# and .NET packages absolutely seamlessly from F#. And you can use the native interoperability mechanisms. You get all the sort of networking interoperability mechanisms. You know, today's functional programming is completely different to what functional programming used to be. Now, it used to be the case that functional programming people had to give examples which are all sort of simple and mathematical, but that's because they couldn't interoperate with anything else, right? Now, if I want to give examples of using F#, I'll give some later on, but there's just thousands and thousands of practical things you can do because you can interoperate with these immense ecosystems. And I'll just mention, I'll talk a bit about at the end about F# type providers, which sort of raise this idea of interoperability to a new level, sort of opening up a space in the language to allow schema and type information to flow in from all sorts of interoperating systems. There are some tensions. You do have, not all functional techniques can be implemented on all standard industry virtual machines, but that's okay because we choose the core, the 80, 90, 95% of what gives big productivity gains in the context of practical programming. Okay, so that's the first tension area, and it's really the heart of the F# language design. When you think about F#, you should think about an interoperating functional first programming language. So I want to talk about a next area of tension. This one is one we nearly all experience in our day-to-day working life now, and that's a cultural tension. It's not all about language design in this talk. It's also about the tensions I've experienced in the journey of F#, and this tension is one that was not causing me relaxation. Okay, originally when I was doing F# at Microsoft, and before Microsoft did this immense embrace of open source. Microsoft is very, very oriented towards open source now, especially anything in the Azure and cloud platform area. This is a real tension. Yeah, the world was going to open source, and Microsoft wasn't back in 2008 and 2009. Things are super good now, and I want to give a quick summary of where we are now with regards to combining the tension between enterprise and open source, because we want the best of both worlds. Okay, I don't think we have a name for what that best of both worlds is, actually. So if anyone can think, what is that name? It's certainly not open source, and enterprise still has this sort of connotation of closed source, and there's something in between, which is roughly where a lot of the industry has landed, and certainly where Microsoft has landed, where we get the best of both worlds between enterprise and open source. So F# itself, as a language design, its specification and its sort of implementation and its core ethos as a language and as a community is open, cross-platform, neutral, and independent. Now that doesn't mean it's completely independent of its contributors. Okay, Microsoft contributed to F#, JetBrains contributed to F# and the F# tooling. We've had a whole range of different people come along to F#, including initiatives in the F# community such as compiling F# to JavaScript, which are, so when we think about independence, it's more about like there's this large zone which is sort of neutral and independent, where everybody agrees to come together and work. Come together and work in. It's sort of like a demilitarized zone or a sort of safe zone where that neutrality plays out. So pretty much all F# language and tooling accepts everything, in fact, accepts contributions. It's all got good licenses. The community itself we've taken has developed in a really interesting way, which was, you don't rely on, it's best not to rely on a company to do your marketing for you, in a way. It's much more effective to allow a self-empowered community to self-market for a language and for an open cross-platform language like this. And so the F# community itself is very self-empowered. You can join the F# Software Foundation, which is a non-profit foundation in the United States, which is just having its elections to its board at the moment. So this is fsharp.org, and you can go out and find out all about the F# Software Foundation there. Now on the tooling side, of course you have to balance it. This is all on the openness side, the cultural openness, the sort of the open source engineering that happens here, and then the community foundation that underlies this sort of thing. But of course you need professional tooling as well to balance that openness and enterprise. And so we have Xamarin providing F# tools, Android and iOS. I work at the Microsoft Mobile Tools division at the moment. I'm a researcher at Microsoft Research, but I'm spending two years with the Mobile Tools division. So I work on the Xamarin tools. The Visual F# tools in Visual Studio are the sort of professional tools for Windows and Azure. You can also use those on Visual Studio for Mac and Visual Studio Code. And then, of course, we have the packaging here for Linux and OS X, and then the Visual Studio for Mac and Visual Studio Code, and other tools, all sorts of other tools you can use here on this side. Underneath it all is this shared component called the F# compiler service, and this is the F# compiler as a library, and it is used to build all this tooling here. And again, of course, it accepts contributions and the like, but it's this one component which is sort of how we get a consistent, simple distribution of F# across through this entire space. So on an engineering point of view, this is what underlies everything. To say we have two great F# to JavaScript compilers. One is called Fable and one is called WebSharper. The Fable one is particularly, for those of you who are into JavaScript, Fable feels like a JavaScript tool. Okay, you get it through NPM, and it takes the idioms of the sort of Java and Node ecosystem and applies them to with F# as the source language. So if you're into F#, if you're into JavaScript, or if you want to do full stack F# programming, then take a look at Fable. There's this wonderful template called SafeStack for doing full stack programming with F#, where you start with Fable on the front end, use .NET Core and Linux on the back end, and so you have F# end to end. You can share a lot of code, of course, between front end and back end. So look up SafeStack, and if you're into full stack programming with F#, it's a very productive combination if you're looking for a full stack programming system that's strongly typed end to end. And so all of this is the setup. And in many ways, this is the core of the source of my recently newfound relaxation, which is why I can come to Malaga and give talks. Which is that all of this allows me to focus on my job, which is to do the F# language design. And we've been able to use this setup now to do F# 4.0, to do F# 4.1. We're just working on F# 4.5, which we're honestly just yesterday started accepting the pull request for F# 4.5. So we're able to take things and evolve the language as well, which is my job. So we started that shift to that setup in 2014, and .NET shifted to open engineering in 2016. Everything's open in .NET, an incredible amount of activity in the open source .NET ecosystem. It's just absolutely amazing what is going on there. And so we've really come a long way in these last few years, and it's a lot of fun, and it's working. The setup is working extremely well. Just run through a couple of things along these lines. Lots of pull requests to the F# compiler. You can go and contribute here. We have a language design process. If you're into this, you can look up the RFCs here, the FS lang design. You can make suggestions here, which might eventually graduate into RFCs, which will graduate into pull requests. and then you can help evolve the language and help us get F# 4.5 and 5.0 and whatever we do after that right as we evolve things. There's just sort of things we were doing in F# 4.0. We did a lot of work on the library, made just the usual sort of things in making the language better. And F# 4.1, we did a lot of work on performance and making sure we've got unboxed data structures available where necessary, and did some work on some bits and pieces of the language design and implementation. Okay, tooling-wise, Visual Studio Code is a massively successful editor, lightweight editor. It has some great F# tooling in it. It's built using the F# compiler services, but it's entirely done by the community. Again, accepts pull requests, all open source. It uses Fable to compile. It's implemented in F#, but uses Fable to compile into JavaScript and then to run inside Visual Studio Code or Atom. It's called Ironide. You can use that with Visual Studio Code. F# on .NET Core. So in many ways, a lot of this is a story of F# becoming a normal programming language. Okay, that F# now is normal on Linux. It's now normal on Mac. It's normal on Windows. And this consistent cross-platform experience is .NET Core. You can start by going .NET New, Lang, F# and doing .NET Build. And you can do that on any of these systems, Linux, OS X, Windows, and many more as well. Okay, that's a bit about Fable. Uses Babel to take F# to JavaScript. Go and look that up, it's a great system. I've talked about the F# compiler service, and I'll skip that one there. So, okay, so that overall picture is how we in the F# world have been able to resolve this tension between enterprise and openness. You know, what is this combination? As I said, it hasn't got a name. It's a good combination. You get the enterprise quality that comes through shipping professional tools like Visual Studio. We've got the openness and the energy that comes from that. We've got the community that comes from something like having a software foundation and an energetic community, a tooling, ecosystem, and an evolution path. And this combination, we'll call it goodness for now. And this is the combination that we've achieved in F#. And in a sense, if you've got your own technologies and you're involved in your own open source communities, working with enterprise partners, it's actually worth just thinking about those 6 checkboxes. You know, okay, our enterprise, as we work with your enterprise partner, are you getting enterprise quality? Or are they actually contributing poor quality additions into your tooling? But that can happen. Not all enterprises do good software development. On the openness, have you got the community covered? Have you got an evolution path going forward? And how's your ecosystem developing? And just think about how you can tick all 6 of these boxes to resolve this tension. Okay, so the next area of tension I want to talk about is the one I alluded to at the beginning. Okay, this one, functional programming and object-oriented programming on the right. And let's take a step back in time, back to say 2003, 2004, late 90s. Okay, what was the situation like then? And again, it's hard to get across what a vast gap there was between the world of functional programming and the world of object-oriented programming. If object-oriented programming was, say, C++ and then gradually becoming Java, becoming dominant back in the late 90s and early 2000s, and then the functional programming world was things like Haskell or Camel or something, then this was a huge distance, and it's a huge cultural distance as well. There's this great book, Modern Compiler Implementation with Standard ML. It's also versions of it with Java. You might have seen it. And each chapter has a little tag in it. Most of them are totally deadpan. It'll say something like garbage collection, the process of reclaiming memory, or something like this. Except the object-oriented chapter, where he uses this tagline on chapter 14, object to express a dislike or distaste for something. So that was how the author, Andrew Appel, expressed way back in the 90s distaste for what was then object-oriented programming. There was a big, big cultural gap between these worlds. So a lot of the journey of F# and Scala, and to some extent Kotlin and Swift and similar languages, has been to find a path through this tension between object orientation and functional. So the F# approach is certainly to embrace what we call object programming, and we make that fit very well with the F# language design, with the core things about functional programming, expression-oriented type functional programming. And we love object programming. We embrace it. It's part of what it means to be a good F# programmer, especially for interop and software engineering. But we don't embrace full object orientation, and I want to talk about that a bit. So here's what some object-oriented programming looks like in F#. Just to run through, there's some inputs to the object that's being constructed. This is the constructor here. This is, say, some object internals. You can have functions and data here in the middle. You have some properties here. You name that this parameter is called v here, v.dx, and so on. And then you have a method at the end. And this is returning a new vector down the bottom. This is a little functional object, okay? And it's entirely fine to use in F#. These are the core language features. You have constructed class types, we've just seen those things. You have object interface types down here, and you have object expressions here. Already a feature you don't have in C#, but you can have expressions here. You put these curlies around it, and you can define an object inline anywhere in your code. You can implement interfaces and the like, a bit like inner classes in Java, just not as complicated. Okay, so that's fine, that looks nice and simple, but when you really, as a language designer, what you have to do is deconstruct things, okay? You have to kind of take this thing called, what is this thing called object orientation? And in many ways we did the same thing with functional programming. And we say, well look, it's all these different things. It's not just one thing, all or nothing. It's actually lots and lots of different things. Dot notation, instance members, static members, implicit constructors, and you have to go through and you have to really work out, do I want this in the language? Is it part of what is a good synthesis or integration between functional and OO actually looks like? So, you know, the question is, what do we do with all of this? So roughly speaking, when you go through this list, you know, there's actually a whole lot of different ideas here. Some of them are great for describing APIs. Okay? There's no doubt that dot notation is a wonderful thing for doing API design, and we love dot notation. Some of them make F# a better implementation language, some of them are part of the .NET interoperability standard, and some of them are just like going a bit too far. Okay? Some of them aren't really needed, and certainly they don't need to be given the emphasis that object-oriented people give them. So roughly speaking, this is where things stand. We have in F# a set of things, dot notation, instance members. You've seen some of these already. These are technical names for various features, and we love these things. Okay, so we embrace these things, interface types and implementations. Then there's a set of things here which we do support. Again, they're just technical features. Some of these are to do with .NET and interoperability, like structs or delegates or performance. So these are more in the area, okay, well, we use them where necessary, use them tastefully, use them respectfully, use them sparingly. And then there's a set of things which really are very rare in F#. And perhaps most tellingly of all, we very rarely do large type hierarchies in F#. They're almost, I mean, they never happen. Almost never happen. We rarely do implementation inheritance. We nearly always prefer delegation. And I'll talk about that a bit more in a moment. We do very few nulls. You can write unchecked.default of if you really want in F#, but you can tell by the fact we make it so long that it's not very common. Okay? So nulls are not a big thing, and we actually don't do much method overloading either. We do a little bit, you can do, say, maybe on number of arguments or something, but we don't do much of that. And so this is, doing lots of this stuff is what I call, say, going down the object-oriented rabbit hole. You don't want to, you can do this method technically in F#, but you don't. It gets very rare, and it's almost always a code smell. And then there's a set of things here which we don't actually support. We don't actually support protected because it's so related to implementation inheritance. We don't support self or wildcard types or aspect-oriented programming, at least not in the language, and so on. A whole set of things coming from the OO world which we can just ignore. We want the core goodness of object orientation, and then we want to drop these things over here. So roughly speaking, we love these things, we tolerate these, we mostly avoid these, and we just forget all about this. Okay. So what does that leave us with? It leaves us with a thing which we call object programming. And object programming is lots of good things: succinct coding, notational convenience, great API design, good naming, good encapsulation, composable abstractions. And this thing I love at the end: make simple things out of complex foundations. Because the simple things delegate to the complex things, and they hide away those things. Whereas badly used object orientation takes objects as sort of this weird single religion. Everything's an object, everything's an object. I'm going to just start by writing class as my very first thing in my program. Object orientation, very tellingly, uses far too much hierarchical classification. Animal, you've all seen it. First page of the OO design book. Animal, cat, dog, and by the end you're writing this sort of thing. So object orientation is also classic for making large abstractions full of failure points, full of null pointer exceptions, for example. What's the point of creating this massive large abstractions when it's just so many failure points all the way through your code? Null after null after null, every single line being a potential failure point. And perhaps with implementation inheritance, when you do implementation inheritance by taking a complex thing and make it even more complex, it should be no surprise that your complexity of your system runs out of control, because you're making complex things out of complex things. And that's not what you should be doing. You should be using languages and an approach to object programming which makes simple things out of complex things by using delegation. And it's the most fundamental lesson for good object programming, is to use lots and lots of delegation. Okay, so in all, in the F# approach, as we combine functional and object-oriented programming to get this thing which we call object programming, we get this positive synthesis, and that's great. Okay, I'll talk a little bit about the practice, about making functional programming work in practice. So we don't actually love functional programming as much as you might think either. I've had a bit of a go at object-oriented programming, but we actually moderate functional programming as well. I've been giving a talk recently which talks about what is bad functional programming. I won't be giving that today, but come along to some of my other talks or watch them online, and you'll see me talk about what is bad functional programming. We characterize this by saying you take functional programming, but we actually call the methodology functional first programming. So you do functional first, but then you use object programming and other techniques where necessary. And I just want to talk a little bit what functional first programming is like. F# programmers love code that is like the combination of these things: succinct, expressive, interoperable, performant, and so on. So I just want to run through what's some code that we might love. I love this code, for example. This interoperates with .NET libraries. It's well tooled. It's succinct. It's expressive. This is a valid F# program. This is a great starting point for programming. F# programmers love their pipelines. This is where you take X and you feed it into some function F. It's the same as applying the function to F1 applied to X, but you put them together in pipelines like this. You'll see lots and lots of this in F# code. You might take every single F# program is absolutely full of this. You take symbol uses, you filter them, you do a parallel map over them, you filter, group by map, and so on. Totally typical pipeline programming in F#. F# programmers love their domain modeling. So this is just some pieces I took from the F# community blogs. Here's some model of errors statuses coming back from a web service. Here's a model of data from someone who's reading, I think, data off the iTunes service in order to do some analysis of their playlists on iTunes. And if you want to know more about domain modeling and domain semantics, this book, Domain Modeling Made Functional, is absolutely fantastic book. And also this one, Get Programming with F#. It covers both of those topics. Okay, recently people have been doing a lot of reactive functional UI programming in F#. So this is a view model in Fable. So it gives you the div, the programmatic HTML. This is using React underneath. So you can see div, button, and so on, depending on whether the page is loading or not. So that's the UI layer, functional reactive dynamic web view. This is something I've been working on in the context of mobile programming. So let's take a look at this. This is an entire mobile app in one file. So this is a Xamarin mobile app here, using a programming model called elmish.xamarin forms. This will run on Android or iOS. Okay, so we have the messages here, we have the model underlying the UI, we have the initial model here, the button is not pressed. We have an update function here. Now this is all pure functional programming. The model is immutable data, and we have pure functional programming here, the update function. And then we have a dynamic view function here. If the model is pressed, there should be an L there that's missing, then we have the label, I was pressed. Otherwise, we show a button, press me, with a command to dispatch a message. Back we go through the update loop here. And we put everything together down the bottom here. We have the init, update, and view. And that is the full application. Okay, and just on composition, we have, this is a good example where someone writes a compiler and then they compose the various phases of the compiler. We have the lexer, parser, and so on. And he said when people kind of see this as the composition at the top level of their program, then you know, it's very pleasing to be able to see how things compose like this. Okay. And just to say, from functional to practical, the functional first approach really does work effectively in practice. So one analysis is of this, of comparing a C# project with an F# project, slightly different project teams. This was an offshore team done in India, this was done in the UK. And so it's the same, they're doing the same implementation underneath. C# project had 5 years at 8 developers, and the F# project took about a year with 3 developers. Here's some stats here. We have 56,000 lines of braces in the C# code. We have 3,000 null checks compared to 15 here. Comments, yeah, not so many in the F#, should be more. We have test code, plenty of tests in the F# code, and then there's the total code here, a factor of 10 difference there. Perhaps the most telling statistic of all is this one, where we have 2,000 try-catch statements in the C# code. 2,000 failure points, 2,000 places where the programmer has had to go and put try-catch because they're so worried about an exception happening. It's an asynchronous system. They were clearly, the complexity was clearly out of control in this system. Here we had, I think, 9 try-catch points in the F# code. Okay, and Simon is in this case, it's not always true, but he is very proud that this system had no bugs on deployment, and he's adamant that in this energy sector in the UK, that F# is a safe choice for doing their software development. And to say this extends all the way through. Jet.com is the first ever unicorn, $1 billion company built on the Azure platform. It was bought for $3 billion by Walmart, and it's a company built entirely on F#. So the functional first programming can be used for very enjoyable, making mobile development, all sorts of other things, but it can be used for right through to build massive companies of massive value as well. Okay, so functional and practical, we've certainly achieved that by interoperability, by being a great combination of functional and object-oriented and object programming. The final area of tension I'd like to talk about is between code and data. And this, it's a technical, it's interesting, like at Microsoft we have maybe 1,000 people or something working on tools for coding, 500 to 1,000. We probably have like 10,000 working on tools for data. And 500, yeah, roughly 10 times as many working on tools for data. And that's because, as we all know, it's the theme of this conference, we're just living through this information revolution, this big data revolution. So the F# approach to this is to say we have to be able to bring data into the language at scale and strongly typed. And so I'm not going to go through too many details, but the technical feature is called F# type providers. And it feels just like a library, but it's actually where you can have plugins to the compiler that give you these spaces of types and data and methods on demand. So I'll just show you some examples of that. So you can point at a CSV file here, and you get strong typing based on, it does, this little thing is called a type provider, and it does schema inference at compile time based on the contents of this. So you get strong typing and strong tooling and an autocomplete here based on the data source. So you get types from your data. Here we have an API. Here's a web API. It returns some JSON. And based on that URL alone, JSON provider over that sample, we get strong typing here over the web API. Okay, so we get types from samples of data. You can get types from schema as well. Here's an example where we're using SQL. We connect to a database with some connection string. We get straight, direct, strong typing into the database. Another example of SQL, you can do this with big data systems like Hadoop and Hive. You take the Hive type provider, you point it at the head node of a Hadoop system, you get strong typing over the scalable data tables in the system. You can do it for web APIs, you can do it for entity graphs, you can do it for old-fashioned things like WSDL, you point at an endpoint, and again you get immediate strong connection to that endpoint. You can even do it between programming languages. You can do it to R, you get the R type provider out, and then you can start using R libraries from F#. There are some people who've worked on a Java type provider to allow you to use Java, interoperate with Java directly from F# as well. Okay, just to say that this is people love this idea that we take internet scale information services and we integrate them directly into the programming language. Okay? So if you haven't heard of F# type providers, take a look, read the papers, go and try them. You can try them on Linux, you can try them on .NET Core, you can try them, you can either take it from the theoretical perspective, if you read the papers, or go and actually try them in practice. Okay, so F# type providers are the way that we manage to bring code and data much more closely together. They've been really successful. People use them in practice at all those companies. Many of those projects use F# type providers. So I encourage you to take a look at that. Okay, so there are a whole lot of other areas which I'm not going to talk about where we've done a similar thing. We've taken two things that are in tension and brought them together. I'll just flick over them. Synchronous and asynchronous code. Numbers and numbers with units, or GPU and CPU. I'd encourage you to take a look at all of those. So just to finish off, remember the Hegel. Go and try and read some Hegel, although it's better to read summaries of Hegel. But in your working life, I hope that you're able to take that idea that these things that are in tension, that are contradictions, work together with other people to help find a synthesis that gives us the best of both worlds between these various themes. And when this is what is at the heart of programming language design. There are all sorts of opposites, whether they're cultural opposites, whether they're technical opposites, whether they're big themes like code and data, or synchronous and asynchronous and so on. And I hope you enjoy your time in Malaga as well, and we all have a lovely, relaxing next couple of days. Thanks.